planet, caught in the act of forming. Not a simulation, not an artist's rendering, but a real-world image captured by the James Webb Space Telescope in June 2025. This is TWA-7b, a Saturn mass planet orbiting a baby star just 34 light-years away. For the first time ever, we haven't just detected a planet, we've seen it. Welcome to Dominion Hour, where the cosmos becomes clear. Today we're exploring one of the most stunning moments in modern space exploration, the first planet ever imaged by James Webb, and what it means for the future of astronomy. TWA-7b is a Saturn-sized gas giant, around 95 times Earth's mass. It's orbiting a red dwarf called TWA-7, located in a young stellar group just 10 million years old. The system lies a mere 34 light-years away, practically next door, cosmically speaking. The planet itself glows in infrared light, still hot from its formation. And that glow is what Webb saw. Floating inside a swirling disk of dust, this young world is actively shaping the system around it in real time. We've discovered over 5 exoplanets, but almost none have been directly imaged. Most are detected using indirect methods, like watching a star dim as a planet passes in front. But this is direct imaging, capturing the planet's own light. It's like spotting a firefly next to a lighthouse from thousands of kilometers away. Only the James Webb Space Telescope had the tools sensitive enough to see through the noise and show us something real. The NASA-released image is stunning. The central star is blacked out using a coronagraph, a device that blocks starlight. Around it, a blue-hued debris disk swirls like a glowing halo. And there, glowing orange against the blue, is TWA-7b, a planet clearly visible, and more importantly, active. It's creating a gap in the dust, likely clearing its orbital path, something we've only ever modeled in simulations before. It's like catching a firefly next to a spotlight and actually seeing the firefly. This image isn't just a breakthrough in science, it's a breakthrough in how we understand our place in the universe. James Webb's power lies in its ability to see in infrared, detecting heat, not just light. Using a coronagraph to block the star's glare, it revealed the planet orbiting nearby. Scientists combined Webb's data with the Very Large Telescope in Chile to create the final composite image. It's not just sharp, it's scientific. We're looking at a planet in its infancy, caught in the act of shaping space around it. This level of precision wasn't possible before, but with Webb's 6.5-meter mirror, cryogenic sensors, and high-contrast imaging tools, the invisible becomes visible. For the first time, we can study not just where a planet is, but how it's forming. This isn't the first gas giant ever seen, but it's one of the smallest and youngest ever imaged. That matters, because catching a planet this early in its life gives us insight into how planetary systems form and evolve. It tells us about disk dynamics, gravitational sculpting, and the timeline of planet birth. In short, it's not just a pretty picture. It's a scientific blueprint of how worlds like ours begin. The implications of this image go far beyond TWA-7b. It proves that Webb can directly image lower-mass planets, opening the door to future missions and discoveries. Imagine seeing Neptune-like planets, then rocky super-Earths, and maybe someday, Earth itself. Webb has moved us from detection to direct observation. It's the beginning of a new way to explore. With this success, Webb is setting its sights on other star systems, Beta Pictoris, HR 8799, and possibly even TRAPPIST-1. These systems are known to have planets, and Webb might be able to image them directly, perhaps even detect atmospheres or chemical signatures. The dream? To one day image a planet with clouds, oceans, or even biosignatures. TWA-7b is the first step toward that dream. This is not CGI. This is real. Captured by the Hubble Space Telescope, this barred spiral galaxy is over 100 million light-years away. Every speck of light, a sun. Every swirl, a cradle of planets. Somewhere in a galaxy like this, a world just like TWA7b may be forming now, and somewhere else is us. That's what James Webb is helping us understand. Not just where we are, but what we are a part of. What used to take decades of theory, modeling, and guesswork, Webb is now solving in a single snapshot. This telescope isn't just confirming what we think, it's redefining how we think. It shows us young planets forming, atmospheres evolving, light bending through time itself. Webb isn't just a scientific instrument, it's a time machine, and we're only beginning to understand what that means. Think about this. If we can see a planet in formation, in another solar system, 34 light-years away, then we can start to ask new questions. Not just, are there other planets? But, what stage are they in? Are there rocky planets cooling, moons taking shape, clouds forming over alien oceans? Webb gives us the power to not just imagine, but to investigate. The more we see, the more we realize we haven't seen. For every TWA7b, there are likely millions of others, worlds in all phases of life, some too faint, some too distant, but each one carries a piece of the story. And the more of them we find, the clearer our place in that story becomes. With every new image, Webb is showing us more than just planets. It's showing us possibility. And this is only the beginning. If this blew your mind, give the video a like, subscribe to Dominion Hour, and comment below. What world do you hope Webb images next? The stars are closer than we think. This is Dominion Hour, your front row seat to the universe. If you enjoyed this journey through Webb's first planet discovery, don't forget to subscribe and share this video with someone who loves space as much as you do. We'll be back with more cosmic stories, stunning visuals, and the science that shapes our place in the stars. Until then, keep looking up.